Okay, no school today, so you guys have video notes, and we're talking about periodic functions. Last class you guys did that ball bouncing activity, and we're going to build on that today. So periodic functions, first of all, is a function that repeats the exact pattern of y values over and over again. So for example, our ball bouncing activity, this was time on the x-axis, that was our independent variable, and height on the y-axis. It reached a maximum height of 6 feet, and most of you guys I think said that to get to the top was 1 second. So it starts out at 0, it would take about a second to get to the top, another second back to the bottom, another second back to the top, and so on, and it would repeat this pattern over and over again. So this function is periodic. It repeats the exact pattern of y values over and over again. So something that's not periodic would be something like this. Okay, it looks like it has a pattern, but the y values are increasing each time, so it's not actually repeating the exact same y values. So this is not periodic here. But our ball bouncing one was. Okay, so second vocab word is period. Period is the distance on the x-axis that it takes for a function to complete one full cycle. So if you look at our ball bouncing activity, what would the period for this be? So the period is 2 seconds. And that's because it takes 2 seconds for it to go all the way to the top and back to the bottom, and that's one full cycle. Our next vocab word is amplitude, and amplitude is distance from the middle to the top or bottom. And because it's distance, it must always be positive. So what would the amplitude be for our function here, our ball bouncing function? So the amplitude, because the middle is at 3, you can think about this cutting our graph in half. The distance to the top of the function would be 3, and the distance to the bottom of the function would also be 3. So therefore the amplitude for this function is 3. And last one, midline. Midline is the horizontal line that cuts a graph in half. So you can see I've already drawn in that line here, and it's at 3, so because it's a horizontal line, what would the equation of that line be? So the equation of the midline would be y equals 3. Now that we've looked at some what periodic functions are and some of the vocab, I'm going to give you guys some practice. Okay, so next thing is looking at graphing sine and cosine. So when you think about the function y equals sine theta, the input is what goes on the x-axis, and the input into a sine function is always this angle theta. So I'm going to mark my x-axis theta, and that is your angle. And your angle could be in degrees or radians. And I'm going to mark mine in radians today. So what I'm going to think about is what value sine has. Oh, and the y-axis, our output, is our sine theta. So it inputs theta, it outputs sine theta. So to graph this function, I'm going to think about the unit circle. And I'm not going to think about every single value on the unit circle. I'm going to think about 0 radians, which has a coordinate of 1, 0. I'm going to think about pi over 2, which is 0, 1, pi, negative 1, 0, and 3 pi over 2, 0, negative 1. So my first question is, at 0 radians, which is right here, what is the value of sine theta? Well, if I come to my unit circle, here's 0 radians. This was pi over 2. this was pi, this was 3 pi over 2. So at 0 radians, sine has a value of 0. And I'm going to go ahead and mark my other 4. And this is pi over 2, pi, 3 pi over 2, and then back to 2 pi. So now at pi over 2 radians, what is the value of sine? Well, the value of sine at pi over 2 is 1. So I'm going to come up here. When my angle is pi over 2, sine equals 1. And then I come here to pi and I say, same question. What is the value of sine when theta equals negative, or theta equals pi? And the value is 0. Okay, because sine is always that second value in that point. We learned that last semester. 3 pi over 2, what is sine? Well, sine is negative 1 at 3 pi over 2. So I come here and I plot my point at negative 1. And then I come back a full cycle around and I'm at 2 pi. So my value for sine at 2 pi is 0. So I come back up here to 0. And you connect with a smooth curve. My smooth curve wasn't that great. But you connect with a smooth curve through those points. If I were to plot every... So now we're going to look at graphing sine and cosine on a coordinate plane. So the input value for sine is theta. And theta is just your angle in degrees or radians. So your input is your angle and your output is the sine of that angle. So we're going to start out thinking on the unit circle, and here I've just drawn a sketch of some of the points on the unit circle. And we're going to start out at 0 radians, which is right here. And I want to know, what is the sine of 0 radians? Well, sine is the y value from your unit circle, so I know that sine of 0 radians is 0. So I'm going to come up here and plot 0 when theta is 0, sine is 0. Okay, now I'm going to come up and I'm not going to plot every single point on the unit circle. I'm just going to plot these 4. So I'm going to go to pi over 2. And I want to know, what is the sine when my angle is pi over 2? So the sine is 1. So I come back up to my graph, and when theta is pi over 2, sine is 1. So I plot that point. So when theta is 0, sine is 0. When my angle is pi over 2, sine is 1. Now I come over to pi and I say, okay, what is sine when my angle is pi? Well, sine is 0. So I plot a point at 0. And I keep going at 3 pi over 2. Three pi over 2 down here, sine is negative 1. So I plot my point at negative 1. And then we complete the full circle and we're back up here at 2 pi, and sine at 2 pi is 0. So I plot that. And sine is a smooth curve. Okay, it doesn't have points at the end. It's not sharp, it's smooth. You would know that if you plotted every single one of the points for every single one of the angles on the unit circle. All right, now I'm going to come over here. I'm going to do my negative side. So I've got negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So negative pi over 2 goes backwards in the unit circle. So that's down here, and sine is negative 1. So I plot negative 1. And then negative pi is the sine value of 0. Negative 3 pi over 2 is 1, and negative 2 pi is 0. So you can see it's a periodic function. It repeats over and over again, and you connect with a smooth curve. Okay? So let's look at 2 examples of questions you could be asked using your sine function. So sine of theta equals negative 1, where theta is between negative 2 pi and positive 2 pi. So basically I'm asking, where does this function equal negative 1 between, between negative 2 pi and 2 pi? So I see that sine is negative 1 here at negative pi over 2, and sine has a value of negative 1 at 3 pi over 2 also. So I would say theta equals negative pi over 2 or 3 pi over 2. And there's only two answers because I'm only asking between negative 2 pi and 2 pi. So now the next question says, when does sine theta equal negative 1? And that's for all theta in your domain. So in other words, any angle. So if I were to add, let's see here, 1, 2, 3 more values, here I would be at 5 pi over 2, here I would be at 3 pi, and then 7 pi over 2. So I go up to 1, down to 0, and then I'd be back down to negative 1. So you could continue on like this forever. So imagine if you're at 3 pi over 2, I've got another answer here, another answer if I keep going. There's an infinite amount of angles that have a sine of that angle equaling negative 1. So the way that you write all of those infinite solutions, and you have more in the negative direction also, is you say theta equals 3 pi over 2 plus, and I want to figure out what do I have to add to this angle to get to my next solution and my next solution. Well, to get from 3 pi over 2 to 7 pi over 2, you're adding 2 pi. Or you could subtract 2 pi to get to negative pi over 2. So you're adding 2 pi or you're subtracting 2 pi an infinite amount of times. So you say theta equals 3 pi over 2 plus 2 pi n, where n is any integer. Okay, now let's go backwards real quick and let's look at the period of this function. So the period of this function is the distance on the x-axis it takes to complete one full cycle. So what is that period? Okay, period equals 2 pi because it takes 2 pi radians to get through the full cycle. Or if you're in degrees, it'd be 360 degrees. Amplitude. Amplitude is the distance from the middle of the function to the top or the middle to the bottom. So what's the amplitude here? Okay, amplitude is 1. Middle to top is 1, or middle to bottom is 1. Remember, amplitude is always positive. Equation of the midline. So remember that midline is the line that cuts the graph in half horizontally. So what's the midline here? Okay, midline is y equals 0 because that's that dotted line here that cuts the graph in half. So period, amplitude, and midline. All right, now let's look at the same thing but for cosine. So kind of the same idea. Input is theta or your angle. Cosine is your output. Cosine of the angle is your output. And this time I'm going to graph the function in degrees. So this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then we're back to 360 on the unit circle. So at 0 degrees here, cosine is your first value, so cosine equals 1. So 0 degrees, I'm going to plot 1. Now I'm up at 90 degrees. So the cosine of 90 degrees is 0, so I plot 0 there. And then I'm at 180. Cosine of 180 is negative 1, so I plot it at negative 1. Cosine of 270 is 0. Cosine of 360 when I complete the full circle is 1. And so we connect with a smooth curve. Now if I wanted to keep going, I would just keep adding 90. So 270 plus 90 is 360 goes here. 360 plus 90 is 450. 450 plus 90 is 540. And then 630, and then 720. And the cycle would just continue on. So I don't even really need the unit circle anymore. I just need to follow the pattern. And I connect with a smooth curve. Okay, and the same thing happens in the negative direction. Negative 90, negative 180, negative 270, negative 360. 0, 1, 0, 1. Smooth curve, no points, remember. No sharp pointy tops or bottoms. Okay, and then there's my graph. So let's look at these examples. Well, actually, let's look at the period and the midline, all that stuff first. So period. So what's the period of this function? So the period is either 2 pi if you're in radians, or 360 degrees, because it's the same thing. Top to bottom, back to top is 360. You could start here, top, bottom, back to the middle. That distance is 360 degrees, or 2 pi radians. Amplitude. What is the amplitude? Amplitude is 1. Same distance from middle to top or middle to bottom is 1. Midline, remember midline is the equation that cuts the graph in half horizontally. So midline is y equals 0. All right, so that's that. Now let's look at these two examples. So we've got where does cosine equal 0? And it's wanting this when theta, negative 2 pi is less than or equal to theta is less than or equal to 2 pi. Let me rewrite that. Negative 2 pi is less than or equal to theta, which is less than or equal to 2 pi. So here I have it marked in degrees, but I know that 2 pi is the same thing as 360, and negative 2 pi is the same thing as negative 360. So it's asking me solutions within this domain. So where does cosine equal 0? Well, cosine equals 0 in a lot of places. Here, 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 and here. So I've got 4 solutions, and it's asking for it in radians. So I'm going to go ahead and change this. I know this is negative 3 pi over 2. I know this is negative pi over 2. This is pi over 2. And this is 3 pi over 2 if I were to convert from degrees to radians, or just look back at the sine function for what your increments were there. All right, so theta equals negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. And those are your solutions, and there's only 4 of them because we're only looking between negative 2 pi and positive 2 pi. Okay, now the next question is where does cosine theta equal 0? And it's for the entire domain. And we forgot to write down the domain. So domain here, the domain is all real numbers because domain is your x values, and this function continues on forever in the x direction. So I would say x is an element of all real numbers. And the range are your y values for the function, so it goes from negative 1 to positive 1. So I'd say y is an element of negative 1 to 1. All right, coming back down here. So cosine theta equals 0. So we want all of the angles. So it equals 0 here, 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 here. So let's say I start out at pi over 2. To get from pi over 2 to my next solution, 3 pi over 2, I'm adding pi, and so on. So every time we're adding pi. So I would just say my answer is pi over 2 plus pi n, where n is any integer. And that encompasses all of your solutions. Okay. Let's come back because I forgot to write the domain and range for sine. So that was for cosine. And now for sine. Domain is actually the same thing because this function continues on forever. So it uses the entire x-axis. So x is an element of all real numbers. And the range is the same as for cosine also because it goes from negative 1 up to 1. So y is an element of negative 1, comma 1. And that's it. So you guys should be able to complete homework 1 now. And if you have any questions, you need to come see me during tutorial.